Right. In the previous class, we have seen like how to verify whether the coordinate points lie on a same line or not. It is collinearity, condition for collinearity. And now we are going to go with like, will the vertices form, these things are of a triangle or not? 0, a root 3 should be this. Yes. So here the point is, can these form the vertices of a triangle? Can these form vertices of a triangle? What do you mean by vertices of a triangle? So it is something like, I am not going with the coordinate locations and all that. So simply like that, let us take this to be A, B and C. So A comma 0, 0 comma A root 3, and this is, sorry, B is minus A comma 0, right? So B is minus A comma 0 and this is 0 comma A root 3. So these are called vertices. The points between which the sides of the triangle are formed. Okay? The point of intersection of two sides of triangle, each vertex is. Now the point here is to verify whether the given points can form vertices of a triangle. Can form vertices of a triangle. How to prove it? For this, we need to go with one of the properties of the sides of triangle. You know it. You have learnt in earlier classes that always sum of two sides, any two sides, maybe of these two sides, is always greater than the third side. If you take these two sides, sum of these two sides, that is sum of the lengths of the sides. So simply I am saying sum of the two sides is greater than the third side. It means it is length. Okay. Like, so we are going to verify that. So for that, first of all, we should know what is the length of each side here. Length of each side. So again we will go with the distance formula. Distance between two points is the length of the side. Distance between the two vertices is length of the side. So first let me take AB. So AB is equal to square root of x2 minus x1 square. So what is the distance formula? Let me write the distance formula here directly, right? So solution. Distance formula. Okay. Distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So now we know how to substitute all that. For that first one I am taking AB. AB is equal to root of first ordered pair, second ordered pair, or first point and second point x1 y1, x2 y2. So x2 minus x1 minus a minus a, because x2 is minus a, so I have taken minus a, minus x1 is a, therefore I have put a whole square, plus y2 minus y1. So what is y2? 0 minus 0, so it is 0. So again the root and square will get cancelled, but here what is that? Within the root, you are going to minus a minus 2a whole square, which is equal to minus whole square is plus, so 2a whole square. Whole square and square root will get cancelled. This is 2a. Let it be equation 1. Let it be equation 1. So our next task is to find, now AB is done. Let us find out BC. So BC, I'm directly substituting. See, 0, x2 is 0, x1 is 1. So minus of minus a whole square plus y2 minus y1. So a root 3 minus 0. So not an issue. You can take a root 3 whole square. So 0 minus of minus plus a whole square is a square plus a root 3 whole square. So a upon square is a square, root 3 whole square, root 3 whole square under root. So a square plus a square, and here square and root will get cancelled into 3. So we are left with 3a square plus a square, which is 4a square again under root. 3a square plus a square is 4a square. How many a squares are here? Here are 3 and here is 1. Total 4a square. Suppose if still any one of you are having any confusion in adding these things. So this is the common sense point. How many a squares are here? 3. How many here? 1. So total how many? 4. 4a square. So now this is 4 into a square. You can split the root here. Root 4 into root a square. Root 4 is 2. A square under root. Root and square will get cancelled. So 2a. So BC is 2a. Let this be equation 2. BC is 2a. Let this be equation 2. Now, what is our target? We have determined this one. We have determined this. Now, our point is to find out AC. So AC is equal to. Now, the next one is AC is equal to. Or it can be CA is equal to. Makes no difference because it is square. The difference inside the square. So, a minus 0 whole square plus a root 3 minus 0 whole square. Not an issue. You can write it like this. So, a minus 0 is a square plus a root 3 whole square. It is something like what you have already got it here. Okay. So, we have already seen that is equal to 2a. Equation 3. We got all the 3 values. AB is 2a, BC is 2a, AC is 2a. What we need to check is sum of two sides must always be greater than the third side. That is, sum of the lengths of the two sides is always greater than the length of the third side. Length, I am leaving it just like that. So, sum of the two sides. Suppose AB plus BC. AB is 2a and BC is 2a. So, what is that? We got 4a. It is always greater than 2a. Either way you can take. Suppose if I am going to add these two, 2a plus 2a, 4a is greater than 2a. Let me add these two, 2a plus 2a, 4a is greater than 2a. That means that condition, that sum of the two sides is always greater than the third side is obeyed in this condition. So, that is satisfied here. Hence, these 3 points form the vertices of the triangle. These 3 points form the vertices of a triangle. And additional information also we have here. See, all 3 sides are equal. All 3 sides are equal means, which triangle is this? Yes, equilateral triangle. So, therefore, I am putting it like this. Equilateral triangle. Equilateral triangle. Finally, this is the conclusion. We are after looking at this only we are able to say this, right? So, to find out whether the given points form the vertices of a triangle or not, what is the condition that you have to remember? The condition is sum of two sides is always greater than third side. Third side. Can you see this? Sum of two sides. In the short form I have written is greater than third side. Any two sides you have to take and you have to compare with the leftover side. Okay, if that condition is satisfied, it means that the three given points form the vertices of a triangle. Here in this example, we got all three sides to be equal, therefore it is an equilateral triangle. Suppose if two sides are equal and the third side is different, so what is that? Isosceles triangle. If all three sides are different, scalene triangle, right? And then, so therefore, you can easily verify whether the three given points form the vertices of a triangle or not. Even after finding, you can establish a relation between these, and then you can say whether the given type of a triangle is equilateral, isosceles, scalene. Even you can go with right angle triangle. How do you verify for right angle triangle? Apply Pythagoras theorem. So the longer side square is equal to sum of the squares of the remaining two sides. If that is satisfied, then it is a right angle triangle. Clear? Is that clear? So all these types of triangles you have learned from class 4 onwards, right? So now this is half, you have to go over this. Right? Pause the video for a moment and then you can copy it down. Yes. Coming back to the next one. Similarly, how you were given for triangle, in a similar manner, if 4 points are given to you, to verify whether they form the vertices of a square or not. This is the point. Vertices of a square or not. What is the rule for any shape to become a square? All 4 sides must be equal. All 4 sides must be equal. Very fundamental point, right? So, thus, I am not going by exact location of the points, just randomly I am taking in order. I am taking in order. Let us name them as A, B, 4, 2. In order means A, B, C, D. Now C, minus 1, minus 1 and D, minus 4, 4. This is A, B, C, D. Let us see if taken in order are forming the vertices of a square or not. So what to find out? AB, BC, CD and DA. You have to find all 4 sides and then verify if all 4 are equal. You are done with. The job is done. So all the 4 points form the vertices of a square. So those who can do quickly verify it. Those who need my help, just look at the video. So 4 minus 1 whole square plus 2 minus 7 whole square. So that is equal to 4 minus 1 is 3, 3 square is 9, plus 2 minus 7 is minus 5, minus 5 whole square is 5 square, which is 25. 9 plus 25 is, so 34 under root. So you got 34 units to be AB. AB is 34 units. Now let me find out BC. This is first point. And the next one, BC. 4 minus of minus 1, 4 minus of minus 1 whole square. You can take also minus 1 minus 4. That will become minus 5. Minus 5 whole square is 5 square. 4 minus of minus 1, it will become plus 1. 4 plus 1 is 5 whole square again. Okay. So either way you can take. And then next the other one is 2 minus of minus 1 whole square. So this is 5 square is 25. 2 plus 1, 3 square is 9 under root, which is equal to square root of 34. Let this be equation 1. Let this be equation 2. Now third one is CD. Let us find out CD. square root of CD. Minus 4 minus of right. So minus 4 and minus 1. So minus 1 minus of minus 4 whole square plus minus 1 minus 4 minus 1 minus 4 whole square. Now see here, minus 1 minus of minus plus 4 whole square. Minus 1 minus 4 is minus 5 whole square under root. Those who are not familiar with these operations, please give a glance here. So minus of minus, this will become plus 4. So plus 4, minus 1 as it is. Minus 1 minus 4 will form minus 5. So it is minus 1 plus 4 is 3. 3 square is 9. 3 square is 9 plus minus 5 whole square is 5 square, which is 25. So thus you got it to be root 34. This is third equation. So we have verified AB to be root 34. We got BC root 34 and CD root 34, and then finally DA. Let us verify. 1 minus of minus plus 4, 1 plus 4, 5 square plus 7 minus 4 is 3 square under root. So 25 plus 9 under root is equal to square root of 34. Square root of 34. Very clear. So you got all four sides to be equal. You got all four sides to be equal, each having root of 34 units. Square root of 34 units. So therefore it forms a square. So these points show that the points so and so are vertices of a square. This is what the given problem is. This is what the given problem is. And we have verified it, and we can see that the sides formed by these four vertices, that means the boundaries formed by these four vertices are of equal size. Thus, these form the vertices of a square. Clear? Everywhere distance formula only. Care must be taken not to get confused with x and y. Don't substitute y1 minus x1. Okay, it is x2 minus x1, y2 minus y1. Or since it is within the square, you can write x1 minus x2 also. But as a standard formula, you are supposed to write it as square root of x2 minus x1 whole square plus y2 minus y1 whole square under root. While substituting, if you substitute it as x1 minus x2 also, there is no harm because you are taking it inside the square. Clear, children? So please pause the video for a moment and then copy it down. Then finally, please give the conclusion here. So therefore, since AB is equal to, BC is equal to, CD is equal to, DA, points form the vertices. These points form vertices of a square. Vertices of a square. So this is how you have to conclude. Here also you have to give the conclusion. As a condition for triangle, sides of the triangle is satisfied, these points form the vertices of a triangle. In both the places you have to give conclusion. So in mathematics, it's very, very important to write the result finally. At the end also, just you can't leave it like this. Right, children? So pause the video for a moment and then copy it down. So now the next part. So almost the whole exercise will be of the same kind. Okay? And somewhere, at some places, you will be asked to find out the area of the triangle. Usually there, a right angle triangle will be given. If right angle triangle is given, you know that the height and base, what height and bases are. Then you can substitute in half base into height is area of the triangle. Sometimes they may be asking you to find out area of the square. You know the formula for it. Side square, because each side is same. So find out the side. Here in this case, root 34 into root 34. Square root of 34 whole square. Square and root will get cancelled. 34 square units. You must write 34 square units, because units of area square units means centimeter square, meter square. You can write square meter or meter square, something like that. So therefore you will be writing square units. And sometimes you will be asked to find out whether they form the vertices of a rectangle. What is the rule for rectangle? Opposite sides are equal. Opposite sides are equal. You have to verify that. Sometimes they may ask you to find out the area of the rhombus. So here their area is equal to half diagonal 1 into diagonal 2. Okay, those who can do, please solve the problems. If you don't get anywhere, post me your doubts so that in the next video those problems can be covered. Right children, is the concept clear? So you should have patience while you are doing coordinate geometry. You need to find out everywhere using this formula, and then in detail you have to find out the sides and then compare and then see whether the respective rules are satisfied or not. As here it is sum of the two sides is greater than third side, here it is all the four sides must be equal. In case of rectangle, opposite sides are equal, right? And in case of parallelogram also opposite sides are equal, right? Likewise you have to check for all the rules whether they are satisfied or not. So I'll take out your exercise and start doing the problems. If you find any difficulty with any of the problems, post me so that it can be covered in the next video. Alright children?